For today's agenda, we're going to spend here 30-45 minutes or so going through residue, and then after that we've got Caleb Stuber's going to go through in detail on everything to keep in mind on the planter from an emergence standpoint as we work through maintenance and such of that nature. When it comes to residue in our environment, the most value that it brings to the table is a resource conservation. But the planter is not as kind to that, and it's going to require more effort and attention in order to be able to maintain that. And then we'll work through the different systems on the planter and how we can understand what their limits and abilities are, as well as their limitations, and then work through some infield scenarios of kind of here's some best combinations for some of the common residue environments that we can run into. Starting on the benefit side of residue, the ability to conserve moisture. Residue is the most cost-effective means of insulation of preserving what moisture we have to work with. Also, due to our winds, the ability to stop that ground from blowing and be able to prevent giving the neighbor more than what they're already getting through that erosion. And then finally, for being able to reduce the stress on those plants in season by keeping that ground temp a little bit cooler and conserving that moisture within that. Then working through to the risk side of residue, each of the different tillage systems are going to suffer of residue in different ways. And so we'll work through both the no-till as well as then through the different tillage system, or the different systems within tillage, and then kind of look at some issues in affecting all of those. Within no-till, the highest risk and the kind of the first component in there is residue into the furrow. The seed needs consistent seed to soil contact in order to be able to imbibe moisture. When we have residue in the furrow, the residue is going to absorb that moisture faster than what the seed can, and so that seed's not going to be able to start the imbibing process until that moisture or that residue has reached its fill of moisture. Then looking further back at the gauge wheels and how the residue is going to end up affecting those, as we have a higher residue load within a no-till system, which is its benefit, it's also kind of its weakness in regards to when we have those varying levels of residue, those gauge wheels are going to be interacting with that, and we can end up manipulating depth of the seed within that profile depending upon what those gauge wheels are doing relative to the surface of the soil. And then from an erosion standpoint, or kind of a mobility standpoint, no-till's going to have a lot higher residue load than the other systems, which is almost going to pose a higher risk if residue starts to blow and move around within that. We're going to end up creating more issues, both from a wind standpoint, as well as if we have a mechanical problem on the issue, the ability of dragging residue and causing issues there. When looking at the different tillage systems, tillage by its very nature is incorporating and reducing surface residue loads. As a result, as we're putting that residue down, it's almost inevitable to not end up having some residue left in the seed zone, which once again, the presence of residue is going to absorb moisture faster than what the seed can, and so we're going to end up causing some issues there. With corn, every hour of delay between the first plant coming out of the ground and the last plant coming out of the ground is 0.9 bushel per hour. So in this scenario where we're climbing up towards 30 some hours after the first plant gets out, that 20 hours is putting us up into the upper teens in regards to yield loss versus if we'd kept it down. We look at Dowdy and Hewlin, these guys that are pushing the limits of yield, they're getting all those plants out of the ground within 3 hours. And in order to get a 600 bushel crop, you have to start with a 600 bushel stand is the ideology that these guys are shooting for. So every little thing ends up counting as we're trying to push through. The disc openers, when we have tillage involved, are necessary to get the seed into the ground, but when we've had that tillage particularly on a lot of our sandier soils, we have nothing then to push against with that disc opener in order to be able to cleanly cut that residue, which inevitably ends up resulting in that residue getting pushed down and creating a hairpin in there and reducing the consistency of environment that seed is presented with. Looking at the mobility of residue, whether it be strip till or full tillage, the strip till leaves more residue in the field and we have more anchor points, but as we're running through there, we're disrupting that residue and we end up increasing our risk of blowing and such within that, so that we can end up creating more issues. And then certainly when we get into a bare field environment, stuff can move around by quite a bit. And within all of the different systems, residue can have a direct impact on our ability to close that furrow, which the furrow has been, a lot of time and energy has been put into understanding and doing our best on the front end of the planter in regards to managing the row cleaners, getting that seed to depth. But the closing system has been something of a frustration and a lack of understanding for a lot of years within that. When residue is present within the closing system, we're absorbing energy that needs to be transferred into closing that furrow, which we can end up either pushing residue into the furrow, we can end up leaving that furrow open, or we can end up going in and not setting the density over that seed so that we're managing moisture, which we can increase our volatilization. In order to solve all of this, we kind of have to start back at the harvest before in regards to how are we managing that residue. Are we creating a uniform environment that will even be achievable for the planter to get through? The combine in cereals poses the most amount of risk. Corn stalks and whatnot and cotton, there's not a lot of residue on that end of the spectrum and such. But when we start getting into those cereals, we've got to be very, very careful and observant that we're keeping that straw spread out so that we're not creating issues like we see on that picture on the left or the right. The tools in the toolbox for dealing with that residue has typically been from a standpoint of, okay, let's till it. Let's manage the row cleaners and such. And the more we end up getting into this, the more we're finding that the value that covers bring to the table in regards to being able to create a more hospitable environment for that planter to run in, as well as solve a lot of the issues we've had with residue in the past. The other thing that covers end up providing is the ability to stabilize all of that residue. And so as those cereals start coming up in there, it doesn't take very long that we're able to get enough stability in there regardless of tillage systems to be able to prevent that from moving around. And then when we have tillage involved, those roots down below the surface, we've changed the environment around it so that we're able to create an environment where we can break down that buried residue faster to be able to create a more hospitable seed zone by the time the planter rolls through in April or May. On the termination end, there's a lot of ideas in regards to what is the correct way to go about terminating it. And each one has its merits within its system. the kind of the general guidelines is we want to look at what is the end result we're going for, and then we can reverse engineer in regards to what we're going to end up doing. So kind of on the short end, if we're going in trying to create a more hospitable environment for cotton, we would terminate it, say, down around that sub-foot line so that we're not over-insulating the soil, but we're cycling stuff through and creating a better environment. Versus pushing it to the far end of letting that cover go until we get to flowering and then terminate it. This is going to provide the most cycling of nutrients, the most amount of additional insulation to protect that crop, and the ability, when tillage is involved, to be able to decompose as much as possible of the residue that's in the seed zone. To work with this from the planter standpoint, we'll kind of break it into two parts. We'll go through all of the iron on the planter first, and then work through some infield scenarios in regards to how to utilize this knowledge. When it comes to the planter, it is a balancing act of performance versus conservation, particularly in our neck of the woods. On the one end, it's easiest for the planter to run in an environment where there is absolutely no residue. But in doing so, we've opened ourselves up to the risk of more volatilization of moisture and more risk of blowing of residue around. Versus on the conservation end, we're going to have no risk of the sun or wind being able to get to that moisture in the soil, but it's going to create a more difficult environment for that planter to be able to plant in a uniform environment. So working down through the planter, the four basic systems that have an influence or an interaction with residue that we need to be keeping in mind are row cleaners or coulters, and then working back through the gauge wheels, and then through the disc opener, and then into the closing system. Starting out at the front on the row cleaners, this is the most critical component for setting the stage in regards to how we're going to work with that. And then within that, looking at the row cleaner itself, there's three basic wheel designs. The straight wheel that was originally brought out by Martin, this one is going to be able to move that residue out of the way without moving any dirt, and to be able to, in a tilled environment, be able to provide the ability to go down maybe a ½ inch and remove some of that residue that's been incorporated into the seed zone, but we're not going to be really possible or feasible to go any deeper than that. Another one of the common designs is kind of a sweeping finger. This one's kind of predominant within the Dawn markets. The thing on this one is, with the way that it's swept, it's going to move a little bit more dirt, but it is also, because it is not as aggressive due to the angle of the way that it engages with the soil, we're going to actually increase our risk of residue being able to slip through it and then be able to have a negative impact once it gets into the row unit. And then we have the shark tooth, which Getter first brought to market. This one is going to move absolutely everything it touches. As a result, we have a higher probability of moving dirt and creating a more lack of uniform environment for the rest of the planter to run on, and open ourselves up to more risk and problems there. Working back within the row cleaner, it kind of comes down to frame design, and there's two basic designs. The cheapest and kind of the first one to market was the pin adjust, which most of these have been eliminated now, but the thing to keep in mind with that is, when those row cleaners are fixed, we're going to have a higher probability of losing residue when we go over the ridges and plowing dirt when we're going through the low spots, and not creating a uniform environment for those gauge wheels. As we work into kind of a floating row cleaner design, there's two basic ones. There's the style that are pushing, which are kind of your Martin, your Getters, and then your trailing within the Ag Focus and the Dawn. The only real difference we're finding between these two is within the pushing style, so your Getters and your Martins, it's going to require less force applied to that row cleaner in order to be able to sweep that residue out of the way when we're dealing with a heavy residue environment on no-till, versus the trailing designs. Bins were kind of more of just trying to keep those wheels engaged in the ground. It's going to require about double the force, which when we start looking at, like on a 12-row planter, that's going to typically end up requiring another 500 pounds of suitcase weights in order to hold that bar in the ground on a 12-row machine to be able to compensate for that. So something to keep in mind within some of those different designs. Working down into the treader wheels around there, the 1.5 inch is kind of the most common, and that is going to provide kind of the best all-around performance within our environment. The ability to provide just enough flotation that we don't end up burying that. There's also the 3.5 inch one, which is going to be kind of the only scenario we're finding that this one is needed is when we get into a very sandy environment within full tillage with very light residue. Because if we start getting more than light residue, we'll end up running into kind of creating flotation underneath that wider band, and we end up negating a lot of the effect of the row cleaner within that. The other thing initially coming out within the fixed ones would be no depth band at all, and the questions came up was, what if we take the depth band off the floating ones? Can we get better performance out of it, particularly in tilled ground? Well, the challenge within that is we need that depth band in order to limit the depth within tilled ground. So basically what we've narrowed it down to is only in the scenarios where a guy is always applying force to that row cleaner do we have a scenario where we could think about taking that off. But within typical no-till environments, we're not finding a benefit of taking it off. So it's kind of you just leave it, and when you get into the tough spots, you have that flexibility. Looking at things from a control standpoint in regards to, yes, we can have the row cleaner on there, but are we allowing it to be able to do its best? Similar to looking at a fixed row cleaner versus the advantages of a floating in regards to not have to go out there and set them as much. When we have in-cab control, we're able to maintain that optimum environment where we're reducing the compromises and to be able to ensure that we're always cleaning that residue out of the way appropriately. Dawn also has this, a little bit more expensive of an option, but still we're able to have that control so we can be able to get in there and not compromise and not have to get out of the cab as often. And then to kind of finish out the intelligence side of that, when we're running the smart firmer, we can look at that clean furrow metric and be able to watch and see what's happening in the furrow. And that clean furrow percentage is what is the percentage of time that we do not have residue in there. So the closer we get to 100, the better environment we're leaving for that seed. The thing to keep in mind is every percentage point we're coming down below 100% correlates to about 1.1 bushel lost yield. So if we're, say, running at 90% clean furrow, we're leaving 11 bushel on the table within that environment. So we want to be keeping this to as clean of an environment as possible. Coming back to between the row cleaner and the row unit, sometimes we can run into a coulter. If a coulter is being ran, they must be set to 1/4 inch above the seed disc in order to not create a false bottom and increase our irregularity of the seed. The challenge is even if we set it at that, if we're not running row cleaners or if a piece of residue gets through the row cleaner and the coulter does not cut it, we've created a hairpin scenario that there's no way that the disc opener can recover from it. So overall in our environment, it's better not to even have these coulters because they're going to create more problems than benefit. Working further back to look at the gauge wheels, the 4.5 inch is the most common on the market, and the thing to keep in mind is these were created for Central Illinois tillage, where you need flotation on a box machine in order to keep that row unit from displacing soil out from underneath of it and such there. The other thing that this ends up causing is the footprint that ends up sitting on is pushing out about 10.5 inches. Our best row cleaner is still only cleaning about a 9-inch pass. We're creating about an 1.5 inch scenario on either side where that thing is being changed depth-wise as we're going through the field, and we're effectively changing the depth of the seed as this is happening and such. The thing to keep in mind is when we are on softer, sandy soils with tillage, unless we have a downforce management system that can remove weight from the row unit, we're going to have to stay with these in order to not end up creating more problems in the furrow. The solution to this is there's a number of different narrow gauge wheels available from 2 inches up to 3 inches, and all of these are going to stay within the footprint of the common row cleaners that are out there to be able to create a more uniform environment for those gauge wheels to run on, because those gauge wheels are directly responsible for what is the depth of the seed and be able to maintain the consistency of that. With these narrower gauge wheels, we're able to stay in there. As we watch this, you'll see a little bit of residue come down, but for the most part, the entire band of that 3 inches on this gauge wheel is staying perfectly clean, and we're not changing the angle of that keaton as we're running through there, so we're able to maintain the consistency of depth and such. Working then inside of that, the disc openers, we want to make sure we're keeping these things in good shape. Caleb's going to spend more time on this here a little bit later on, but just for kind of a quick starting point, they're 15 inches on most of them. On your Case 1200s, those are 14 inches. When you lose a half an inch, it's time to replace them, and in that we're able to maintain a better overall experience for that to be able to cut through. Now, once again, if we have residue hairpinned, we've already lost. So anything we can do to keep it proper so that we can cut that residue on the surface of the ground so that residue never gets taken below grade, we're going to create a better environment for that seed. While we're in there, we want to double check shimming. For the common 3.5 millimeter blades, if we're planting corn only and we're staying at that 2 inches and deeper, we can stay at that inch to inch and a half of blade contact. What we're finding is as we shallow up to the 1.25 inches or shallower, say down to 1/2 inch for cotton, we no longer have the same amount of soil pressing against those disc openers in order to create the proper furrow. So what we're finding is we're having to shim these things tighter for the shallow planted environment so we do not leave a W in the bottom and end up creating variability to depth on that. As we continue to work back, we start getting into closing. And the thing that we need to start with is understanding what is proper closing. The starting of closing is that basically there be no air gaps, that we've completely reset the density of the soil around the seed, and that we've set the density over the seed to a correct amount to be able to conserve moisture and yet still be able to have a mellow path to the surface. There's 4 basic types of closing systems out there. Most common is going to be the stock rubber, and then you get into kind of the the copper heads for kind of your poly spikes, your Thompsons for your steel spikes, and then we get into the 2-stage systems. Starting with the rubber, this one has the most susceptibility to residue. Due to the footprint of that unit and the amount of energy that it can end up absorbing causes a lot of issues in regards to get it. The other thing is, even if we get it correct, being we're pushing down on either side, it's trying to close from the bottom to the top, but we end up leaving the soil in the middle too loose, and we end up volatilizing moisture out of that and running a bit weaker than what we should. The poly-spiked one is going to do a better job of being able to reach through the residue in order to close underneath of it. The challenge is we're going to do a good job of fracturing up those sides to an extent depending upon the density of the soil. The problem is we've still left that middle on the loose side, and we're going to end up volatilizing moisture out of that more than what we want. When we get into really tough conditions, the spike closing systems, and there's many different variants of this, is going to typically do a very good job of the aggressive side of breaking stuff up, but there's no way to set the density on that, so we're opening ourselves back up to moisture volatilization. As we start getting into the two-stage systems, we'll start with the case style, which both Case and Ag Focus are currently running. The thing to keep in mind with these is this is designed as a system, and this is kind of the weak point of Ag Focus taking the Case design and applying it to a deer row unit, is this particular style of two-stage system with the sizing of everything in there, it is dependent upon the running of a reduced inner diameter gauge wheel. And that RID gauge wheel is to create an additional height to the furrow of about that much, because that first stage disc is not going to go below grade, but just a slight amount, and it's relying on all of that material to be able to attempt to close it. And when we have very ideal conditions within full tillage and whatnot, it's very possible to achieve that with this system. Also, Martin's developed a razor wheel to be able to allow it to be a bit more aggressive in tougher environments. We've seen that help improve that. The other challenges on the second stage on there is there's very little adjustment to that. So typically as we get into tougher environments, we're not carrying enough weight on that in order to set the density over the furrow. We get on the softer end, it's not as big of a deal, but as we start getting into those tougher environments, these things are going to fall apart very quickly. And then the final of the two stages, Precision's Furrow Force. Yes, it looks similar to a Case, and in some ways there's a lot of things we learned off of it. The big difference is starting with the first stage notched wheels, and actually one thing I should back up, on the smooth wheels, the amount of force that can be transferred into the furrow is fairly minimal, and so any bit of residue coming underneath that disc opener is going to negate that ability to close that properly. The notched ones are going to help on that a little bit. So within the notched larger first stage wheel on Furrow Force, we're actually setting that wheel down next to the seed and going in and completely fracturing that soil all the way around that seed. And a lot of the comments of once running it, you can't find the seed, which is a good thing because that means the roots of that seed are not going to end up running into density changes once we get into the field. And then finally, the second stage on there is going to go in and be able to set the density, have the flexibility that the operator from within the cab can be able to make the necessary changes based upon what they're running into within the field. What we'll typically end up seeing is as we're resetting the density of those sidewalls, and we're running on about a 3.5 inch band, is the furrow is going to end up coming up a little bit, maybe say about a 1/2 inch as that soil's restructured. And then as that second stage comes into it, we're able to set it back down and be able to put enough pressure to it that we don't lose moisture, and yet it's still mellow enough that the seed can get out of the ground. Within residue, due to the notched first stage wheels, we're able to get through that residue, but then coupled with the ability of this system to have a very wide range of pressure application, we're able to adapt as we get into some of these very challenging environments. So this field on the right was shoulder high rye, no-tilled into without row cleaners. We'll get into it a little bit better, but it's be able to go in, unify that furrow back together and close in even the most challenging, and we'll get into some of the more easy environments here in a little bit. When it comes to kind of taking all of this and putting it into the application, work through these 4 scenarios and kind of look through, okay, here, what's the best case scenario, but what's the principles that we're applying within each of these scenarios to be able to adapt them out into variants of it that these don't specifically end up addressing. Starting with the most resource depleted environment would be kind of a no-till dry land. We'll start on the easier end of the spectrum of assuming we're going into cereal residue. Within this environment, what we're finding is, assuming we have an even amount of residue of what we established back with the harvest before, we can run the row cleaners lifted due to what little bit of residue we're going to get into the furrow is going to typically end up being less than the yield loss due to the extra volatilized moisture due to a perfectly clean furrow. So this is a very painful one from the standpoint of I want that furrow clean, but in regards to getting a crop, we want to preserve and leverage that residue. Staying with a narrower gauge wheel is going to allow a less of a impact if there is any slight variances in residue thickness. And then when it comes to closing this, what we found ends up working best is to be able to give the operator the flexibility in the cab to be able to set the density around that seed. And in dry land, it's very critical to set the density around that. What was interesting is on a plot here west of town, the operator said, it's sand, it's easy to close, we don't have a problem. It's like, okay, fine, let's at least learn. We get out there, this is on Milo. This is the red-headed stepchild that no one cares about and it isn't responsive to care. What was interesting is we put furrow force on a pinch row, so this is the most difficult environment and whatnot. And yes, by setting the density over the deer wheels, we were able to run about a 5 bushel advantage over that. The thing that we was not expecting, look at that wing on there with the stock deer system. We would normally assume that pinch rows are going to yield less in the wing because we've overcompacted it. In this environment, and from between this and some other plots, what we're finding is we've been leaving this ground too loose and we're volatilizing moisture out of it due to our more severe conditions and such. So we got to be paying close attention to this, and if we can take that, apply it back to the irrigated, there's some water efficiencies to be gained out of this, as well as for the dryland guys, the ability to be able to make a better crop. The most challenging one is where we start getting into varying residue loads here, milo stalks and your corn stalks. If we can go in and stay between the rows and not go over corn stalks, we're going to be fine. But if we can't, what we're finding is if we can go in and set that row cleaner so that it's running, say, just the fingers are just a 1/4 inch above the dirt, we're going to be able to knock back that heavier residue, maintain the consistency for the gauge wheels, and yet leave that duff in place to get as much insulated factor out of that we possibly can. Certainly the narrow gauge wheels are going to help on that, and then be able to have the flexibility of being able to set the closing system from within the cab to be able to set that density and be able to conserve as much moisture as possible. As we move into the irrigated space, this one opens up a lot more opportunity and a lot more joy because we have a lot more tools in the toolbox because of the flexibility water gives us within the system. We'll start with the even environment, which is a bit easier, and then we'll get back into the uneven environment. What we're finding is when we're in an even environment, which typically this is going to be your planting into some sort of a cereal crop, or if on corn we're doing silage or something where we've removed a lot of that biomass. And in order to create the most hospitable environment, the ability, and like for this gentleman, they've gone in there and they put a number of different covers down in the fall, created a very even, even bed for that planter to run on, so we didn't even have to run row cleaners on this and be able to get it in the ground. The interesting thing on this particular one is half of the planter is the stock case closing system with the Martin razor wheel, so we got a bit more aggressive first stage disc. The other half of the planter was furrow force. When taken to yield on silage, we got over a ton to the acre benefit of, in that severe environment, to be able to crank that pressure down, be able to ensure that that furrow was completely closed, and do what we can to leave that seed with a healthy environment. Working to the more challenging one, but we have a bit more flexibility, would be when we're going into corn stalks. What we have found is, at this point in time, we have not found a cover combination to be able to create enough biomass to unify this environment. As a result, we're going to have to end up running the row cleaners, some sort of management tool such as Clean Sweep, where we can be able to apply, typically in these environments, 30 to 40 PSI down on that row cleaner in order to be able to sweep that residue to the side but not move dirt, is going to create a more hospitable environment for those narrow gauge wheels to then run on and be able to work through that. And then certainly this is going to be one of the more challenging closing environments because we're going to have a lot of structure, so this is going to require a more aggressive closing system to be able to ensure that all that ground is unified, and then certainly the ability of setting the density from the cab. Furrow force is going to provide a more hospitable environment for that crop. As we start working into tillage, starting on the strip till side, the challenge with strip till is being we see more residue on top of the ground, we think we have a better seed zone environment. The challenge we'll end up running into is we have yet to find a strip till rig that does not end up putting residue into the seed zone. And so this ends up creating a very frustrating environment to end up running in. The best scenario that we found to be able to manage this is if we can go in and immediately after harvest, go ahead and get that strip till done, and then get a light rate of cover on that to be able to stabilize that residue so we don't have stuff blowing around due to the disturbance of that strip till rig. And then to be able to run the row cleaners with just enough force to be able to kind of sweep back what covers come up. And then if there's any larger residue left over from that strip till pass, to be able to sweep it out of the way so that your narrow gauge wheels can be able to not end up changing the depth. The one caution is as we get into sandier soils, if we don't have the ability to remove weight from the row unit, we're probably going to have to stay with the wider gauge wheels in order to not end up blowing that soil out from underneath there due to the ability of managing that weight. The proper closing is still critical, and certainly the closer we end up getting to correctly managing the density over that seed, the more moisture preservation we're going to have to work with. Working on to the full tillage side, this one is probably the more frustrating of the bunch. Is as we've tilled, we've mixed all that residue in, and we've created a very miserable seed zone. If tillage is necessary in order to manage compaction or whatever's or reduce some of the surface residue loads for more sensitive crops such as cotton, if we can get that tillage done as soon as possible after harvest, get the grain drill out there, get a light cover on it, get stuff stabilized. The main objective we're going for out of this one is to be able to get that residue up just tall enough to be able to prevent any blowing of residue, but the most important thing is to be able to accelerate the decomposition due to those living roots within that seed zone to be able to create a more hospitable environment. Depending upon the subsequent crop is determined how long this can be allowed to grow. The longer we can let it grow, the better we're going to be able to decompose some of that residue in the seed zone and be able to create a more hospitable environment. Within this, looking at the closing system, it was an interesting one of we ran into the same scenarios we did on the dryland milo. The grower on this one thought that I have a compaction problem. We'd put tracks on the planter to try to mitigate that. And as we're looking through this of working things through, yes, Furrow force did create the best environment on that pinch row, but when we start looking at the versus the wing, Furrow force did worse on the wing than it did in the pinch row, which comes back to we're over-tilling, which ends up asking the question is, okay, what are we leaving on the table due to this? We're going to say this was on a loam field out of Hartley, or a couple of fields out of Hartley there. Can we end up leaving this ground more intact and not have a yield benefit? Are we assuming too much to think that we have to till because the guys on the heavier soil in Illinois have to till? And start asking the questions and start considering the tests of let's find out how much compaction we can actually let this soil have before we end up going backwards on yield and be able to conserve that moisture, reduce that iron cost and such of that nature. So in summary of this, we've kind of gone over the risks and the benefits that residue ends up presenting, looking at all of the different tools on the planter, what their abilities are, what their limits are, and then work through a few infield scenarios to see how do we adapt and best manage within each of these different scenarios. Certainly these are just scenarios. Certainly talk to us and whatnot at your need in regards to how to adapt these principles down in your specific environment in order to do the best you can within that.